we're going to have a little talk about capacitors and how they work in AC circuits. So just start by thinking back about how capacitors work in DC circuits. When we close the switch, the current flows onto the capacitor plates and sets up an electric field between the capacitor plates. As that charge builds up on the capacitor, the voltage increases on the capacitor. So now when we take the capacitor and we apply an AC voltage to it, an alternating current, that means we're charging up the capacitor one way, discharging it, charging it the other way, discharging it, then starting again, charging it, discharge, charge the opposite way, discharge. And so what that means is that the capacitor voltage is going to oscillate up and down, out of phase with that current flow on and off the capacitor. In fact, its maximum voltage is going to be at the instant when it stops charging, which is when current flow is zero. And so when current is zero, the voltage of the capacitor is going to be high, and when current flow is maximum, that's actually the point that the capacitor voltage is zero. And we find that because the capacitor builds up a voltage across the plates, it acts as though it's a resistor in an AC circuit. When we apply an alternating current to it, we see a voltage appear across it, and that voltage is proportional to the current. We've got V equals I XC applying. XC is the reactance of the capacitor, and that's a quantity that we create to help understand how a capacitor works in an AC circuit. Thinking about what that reactance depends on, it depends on the capacitance, the size of the capacitor. So when there's a greater capacitance, that means that it's going to take longer to charge up, and that means if there's a fixed charging time before that discharging occurs, it's going to get a lower proportion of its total charge, and therefore a lower voltage. We think about it as having a smaller reactance. Likewise, the frequency of the AC supply affects the reactance of the capacitor. The higher the frequency, the shorter that charging cycle is, and therefore the lower the reactance is. So we can actually write out an equation for reactance. The XC is 1 upon omega C. Omega is the angular frequency of the supply, and C is the capacitance. More useful though is the 1 upon 2 pi FC. Much more often we know the frequency of the supply rather than the angular frequency.